All right, question number 5. So this is one that is ideal for doing substitution. If you notice, the x variable is kind of isolated. It doesn't have a number or coefficient in front of it. And all we have to do is move this 5y over and we'll have x by itself. So usually when the problem is set up like this, substitution is better, or it's easier to do substitution, but I still like elimination. I want to show you both on this problem, and then we will go from there. So it will be good to kind of see both. So first I'm going to do it with elimination. I think elimination is easier, but I'm also going to do it with substitution. Or I'll do substitution first because that's what it's pushing us to do substitution. And I haven't done a full-blown substitution one yet. X plus 5y equals 14. And then we have negative 3x minus 15y equals negative 42. Okay. So to do substitution, I need to isolate one of the variables. So I'm going to use equation number 1. I'm going to call this equation number 1, first one. I'm going to move the 5x over, and then I'm going to substitute. So I have x plus 5y equals 14. I'm going to subtract 5y from both sides. This will give us x equals negative 5y plus 14. Okay, so this is what x is equal to. I'm going to replace x in the second equation with this whole expression because x is equal to negative 5y plus 14. So right here I'm going to plug in negative 5y plus 14. So I'm going to come bring that down. Negative 3, and instead of x, I'm going to replace x with, or substitute it, 5y plus 14, and then finish the rest of the equation. Minus 15y equals negative 42. Okay, so we're going to do negative 3 times negative 5y. That's going to give us positive 15y. Negative 3 times 14 will give us a negative 42. Bring down the remaining part of the equation. Minus 15y equals negative 42. Okay, so we're going to simplify. So we have a positive 15y, negative 15y. They're going to cancel each other out. So my one variable that I had got eliminated, and what I have left is negative 42 is equal to negative 42. Okay, I could add 42 to both sides, but it wouldn't matter. I'll just get 0 equals 0. So if all of your variables get eliminated, and what you end up with is a true statement, then that means there's infinitely many solutions. These are the same line, same equation, infinitely many solutions. Okay, infinitely many solutions. Now, likewise, you could have done this with elimination, and you would see just about the same thing. So x plus 5y equal 14, negative 3x minus 15y equals a negative 42. Now here I could eliminate either x or y. What you want to look for is which one would be easy to manipulate. X would be easy to manipulate. It already has opposite sign. This is positive, this is negative. I just need the number to be the same. Same thing with y though. Opposite sign, that's negative, that's positive. I can multiply the smaller one and get it equal to the bigger one. So in order to do that with elimination, I would multiply this top equation by 3 because I want to get rid of x. So if I do 3 times x, that would give me a positive 3x. 3 times 5y will give me a positive 15y. And 3 times 14 will give me 42. When you add these two equations up, negative and positive will zero out. Negative and positive, 0 out. Negative, positive, 0 out. So you end up with 0 equals 0. Same result. It's a true statement. So you got infinitely many solutions. Now, second part is they want you to write a expression that represents infinitely many solutions. So here's where solving for a variable comes in place. We're going to write an ordered pair. We're going to have an x, y. Okay. So because I've already solved for x, I know that x is going to be equal to this expression. So I'm going to say x is equal to negative 5y plus 14. And then comma, y is going to be itself because I didn't do anything with y. So y is going to be independent. Once I plug in y, I can figure out what x is. So y is just going to be y. That's how it's going to be. So you have both terms in terms of y. X is in terms of y, and y is just itself. And y can be any real number. So they will ask for something like this. You can solve for x or y. This time it just happened to be easier to solve for x because it was already by itself. So this is a nope, not dependent. Yes, dependent. That's the term. That means they're all the same. So here's where I plug in this expression. So I'm going to do negative 5y plus 14. And then over here, y. And then what they want here is the independent variable, which is y. Since it's not in an expression, y can be any real number. So y, just any number we pick, we can plug in because they're all going to be the same. Works for every number. Just thinking about it. I wonder if the system froze up on me. Just pause. Refresh. Sign back in. Go back to college algebra. We were on 9-1. And we're going to continue. It's the same equation. So we said dependent, and then negative 5y plus 14. This was just y, and y can be any real number. Okay, there we go.